All right, I'm going to make a video today using the ZTest and TTest from the TI-84 calculator. So I've got a question here that is going to be quantitative, since those are both tests for quantitative data. All right, so I'll read this. The IQ value of people is normally distributed with a standard deviation of 15. A random sample of 50 people were tested to see if the average IQ value is above 100. So the mean of the sample is 106, and we're using a significance level of 0.05. So what would have to be changed if the sample had been only 25 instead? So I'll do it using the given information where n is 50, and then we'll try it with n is 25. So just from our first little paragraph there, piece of information that we're given is n equals 50, x bar is equal to 106, the sample mean, and the sample is 106, and alpha is going to equal 0.05. Significance level is 0.05. That's what our alpha level is. All right, so we're doing a test of hypothesis, so we need a null and alternative hypothesis. This is only one sample. I know we're going to do it again with n is 25, but this is just one sample. So our null is the mean, mu, is going to equal 100. We always use the equal to sign for the null. It is quantitative data, so we're dealing with a mean, that's mu, as the population. And 100 is what they're asking us to take a look at. So there's 100 here. And specifically, they want above 100. So that means my alternative, HA or H1, whichever you prefer, mu is greater than 100. So this is the test that we're going to run. We have an alpha level of 0.05, and we're going to test strictly greater than. Okay, so let's get the TI-84 out and let's put it to work here. So I'm going to run the stat. We're going to go into tests. And the very first one is ZTest. The reason we're using ZTest is because n is greater than or equal to 30. Okay, so this means use the Z. All right, so we have statistics, we use stats. Mu sub 0, that's this 100 here. So we're putting that in. That's what we're testing. Sigma is actually given here as 15. If we don't have a sigma, the sample standard deviation is fine. X bar is 106. N is 50. And we are testing greater than, so we're going to grab the third option for that. So this is what your display should look like, and now we're going to hit calculate. All right, so this puts out a test statistic. So Z equals 2.83-ish. And the other piece of information is that p-value, and that equals 0.00234. Okay, so we could compare the Z to the one-tailed Z of alpha, but let's use the p-value since we have that. So the rule for p-value is if the p-value is less than or equal to alpha, then we reject the null. And if it's greater than alpha, we fail to reject. So here, our p-value equals 0.00234. That is less than or equal to 0.05, which is alpha. So we reject HO. And that is a one-tailed test using quantitative data and a large sample of 30 or more. The second part wants us to change the sample size to 25. So let's scroll down a little bit and do that. See if we can still leave our n in there. So I guess our new n is 25. This is less than 30. So this is small. So we need one other piece of information. We need to have the fact that we're dealing with a normal distribution. So sample is normal. So we can use t. Okay, the x bar and the alpha are going to remain the same. We're not going to worry about that. We run the same null and alternative. The only difference is we're going to use the t-test instead of the z-test. So up here, we used z-test. Here, we're going to use the t-test. All right, so we will grab that with the calculator. It is number 2 instead of number 1. All the inputs look the same except for 1, and 1's very close. So 100 is the same, 106 is the same. It's asking for S. We actually didn't list S, or we don't have the S listed for the problem, but sigma is great. We can use sigma if we have it. That's good. Our sigma was 15. So I didn't rewrite that down, but I should have written it down in the first place. And this n is now 25. We keep it greater than, and we check our, in this case, the t-test statistic and the p-value. So our t-test statistic is 2. So here we have t-test, t equals 2. And our p-value is equal to 0.0285. That is still less than alpha, still 0.05. So again, we choose to reject. Well, this means we have evidence to indicate that the true mean IQ is above 100. And that's how you use the z-test and t-test on the calculator.